Hi everyone, back to this video or this example 5 again. I stopped, but I hadn't tried to sketch this thing yet, and I don't want to have to recreate the whole video, so you're going to get this in a separate video. So the sketch part, in fact, I'll even get a new piece of paper so that I can kind of summarize all of this for you. Let me snag some here. Okay, so here's what we know. We have a first derivative sign chart, and we've marked off, let me see what we did before. Okay, so 0 to 4 would be pretty good. So all the interesting info we had was between 0 and 4, I believe. 2, 3, 4. Okay, so those are my x's. So what we know is that f prime, just looking back up at this, f prime was, oh, maybe I do want to go a little further. Here's -1, was -0, positive, 0, negative. So this is what we know about f prime. And then we could put it on the different chart or the same chart. We just did some information finding about f double prime, so I'm just going to summarize that here. We know that at 0, 1, 2, 3. Okay, so 2 plus, so right around here, this is 2 plus root 2. We know that the second derivative is 0, and at 2 minus root 2, we know that the second derivative is 0, and other than that, it goes for this whole stretch plus, minus, plus. I'm missing, this is still minus over here. Okay, so these are our sign charts. We also have our original function h of x equals x squared e to the negative x. So to put this together and try and get a decent graph, I'm going to just line this up where it was 0. Okay, so here's my y-axis. And looking at my function, I can actually really easily get at least one point. I can tell that it goes through 0, 0. And I can also tell that it goes through, so let me just list these here. When x equals 1, I get 1 over e, which is around 1/3. Not exactly, but kind of close to 1/3. E is a little less than 3. Okay, so there's a couple of points for me. So let's see. We know, where'd it go? That there is a local min at 0, 0. So this is going to be a local min. We know that there is a local max at 2. So let's see if I can figure this out. 0, 1, 2. Okay, so when x equals 2, if I plug that back into the function, I get 4 over e squared, 4e to the negative 2, which is kind of in the ballpark of 4/9. So it doesn't look like we're getting very high or very low. So I'm just going to say this up here is 1. 4/9 is a little less than 1/2. So it goes through 2, and just shy of that, 2, 4 over e squared. Okay, and then we know it went through 1, 1 over e, which is around 1/3. Thirds will be about here. Okay. Okay, so we know that the function starts off, and everywhere, here's 0. Everywhere to the left of 0, it's increasing and, oh, hold on, I'm saying it backwards. It's decreasing and concave up. So this is f prime negative, f double prime positive, decreasing concave up, which is this sort of shape. So I'm going to start off with a decreasing concave up shape. And then I know right at 0, it's still concave up, but now there's a flat spot. And then it switches to here. This whole stretch in here is positive, increasing concave up. So we hit our flat spot. There's our minimum. I know that then right around 0.6, 2 minus root 2, I hit an inflection point. So somewhere right in here. So it stays concave up until I hit that. And then it switches to increasing concave down, which looks like this. I should draw that over on this side. Increasing concave down, and it stays that way until I get to the maximum. So it stays increasing concave down all the way over to my maximum. On the other side of my maximum, it's still concave down, but now it's decreasing. So now I'm expecting this sort of shape. And then, I might want to inspect the original function just a little bit more. Notice that when x is a really big negative number, I have a really big negative number squared, and then this is e to a really big positive number. So that's a huge positive number multiplied by a huge positive number. That's telling me go off to infinity, and there it is. If x heads to positive infinity, then I have infinity squared, so huge positive number. And then e to the negative huge number, this actually gets really small. E to a really big negative number is really close to 0. So as x goes to positive infinity, I have x squared going to positive infinity in a hurry, and I have e to the negative x going to 0 in a hurry. And the question becomes who wins. And if you're not sure, you can always go to your calculator and plug in some big numbers. But something you may have picked up along the way learning about these functions is exponential functions always end up growing, or in this case decaying, more quickly than power functions grow. So the exponential is always going to beat the power function no matter what that power is, which means that we have an interesting global behavior here. This thing has a horizontal asymptote, so it's approaching 0. So the end here, hold on, 3, we have an inflection point just after x equals 3. So 3, let me just check this out. If I plug 3 in there, I get 9 over e cubed. So that's in the ballpark of 9 over 27, which is about 1/3. Okay, so here we're going to stay decreasing concave down until we hit the inflection point. Oh, that was a little further over, sorry. And then we're going to switch to decreasing concave up forever. And that's just this gradual upward bend that keeps us above the asymptote. So there's a sketch of this thing with all of this information involved. Thanks for watching.